In this lesson, you will learn how to solve systems of equations by elimination. What is the solution of the system of equations? So with system of equations, your solution is going to be an ordered pair, x, y. So to figure out what x is and y is, the first thing you want to check with elimination is you want one negative, one positive, and you want the same number. So if you look in front of y, we have one negative, one positive, and we have the same coefficient of 1. If your problem is set up like this one, then you're ready to just go ahead and solve by adding the two equations together. When you do, your y's cancel because positive 1 plus negative 1 is 0. 1x plus 2x is 3x, equal to 7 plus 2, which is 9. And when we divide by 3, we end up with an x of positive 3. We're now going to find y by taking the x of 3 and plugging it into one of the original equations. So one of the original equations is x plus y is equal to 7. It's the first equation. So if I substitute x with 3, I can now find y by subtracting 3 on both sides. And I see that y is positive 4. So my solution written as an ordered pair, 3, 4. For the try it, go ahead and pause the video. See if you can complete this one on your own and then unpause to check your solutions. All right, so we have that one negative, one positive with the same number. So our system is ready to solve. We go ahead and we add the system. Negative 4y plus 4y is 0. 2x plus negative 1x is going to give us a positive 1x, equal to 2 plus 3, which is going to give us 5. So we have an x of 5. Now the second part, take one of your original equations, doesn't matter which one. I am going to use the first equation. And substitute the value you just found. So we just found x to be 5. So we're going to completely replace x with 5 by placing it in parentheses next to that 2. And now we're going to solve. 2 times 5 is going to give us 10. We're then going to subtract 10 on both sides. Negative 4y is going to equal negative 8. And then we're going to divide negative 4 on both sides. And we end up with a y of positive 2. So our ordered pair solution is 5, 2. All right, I want one negative, one positive, and I want the same coefficient. If you look in front of x, I don't have that. If you look in front of y, you don't have that. All right, so what we'll need to do is we'll need to get them the same. So you can either focus in front of x or you can either focus in front of y. I am going to focus in front of y. Right now, in front of y, I have a positive 3 and a positive 2. To figure out what is going to go there, you can go off to the side of your paper and find the least common multiple of 3 and 2, which if you do that, you'll see the least common multiple is 6. So you want a 6 as the coefficient on y, one negative, one positive. So my first equation, I already have a positive. So if I multiply that equation by 2, it's going to give me that 6y that I want. My second equation, I'm not only going to multiply it by 3, but I'm going to multiply it by negative 3 because remember, I want one of them to be negative and one of them to be positive. When you multiply, make sure you distribute. You multiply by every term in those parentheses. Rewrite the new system. So our new system is 2x plus 6y is equal to 6. Second equation, negative 6x minus 6y, that's what we want, is going to equal 6 times 3 is negative 18. We're then going to add this system. 6y plus negative 6y is going to cancel. 2x plus negative 6x is going to give you negative 4x. Equal to 6 plus negative 18 is going to give you a negative 12. We're then going to divide negative 4. And we'll see that x is positive 3. Knowing that x is positive 3, we can find y. I am going to use my first equation, substitute x with 3, and then I have to solve this equation. Subtracting 3 first, 3y is going to equal 0, and when I divide 3, my y ends up being 0. So my ordered pair solution is 3, 0. Go ahead and pause the video, complete to try it, and then unpause to check your solution. Okay, so if you look in front of y, you already have your 1 negative, 1 positive. We just need to get those coefficients the same. 2 and 5 have a least common multiple of 10. So we need their coefficients to be 10. And again, we already have 1 negative, 1 positive, so we don't have to worry about that. So for my first equation, I would need to multiply by 5 to get a 10 there. Second equation, I would need to multiply by 2. And again, you're going to multiply 5 by every term that you see, and the same with 2. You're going to multiply it by every term that you see. And rewrite the new system, which is 5x plus 10y equal to 20. My second equation is going to be 4x minus 10y equal to negative 2. I'm going to add my system. My y's cancel. I end up with 9x is equal to 18. And when I divide both sides by 9, I end up with an x of positive 2. Knowing x is positive 2, I plug that back into one of the original equations. I always use the first equation, replacing x with 2. We subtract 2, and then we divide by 2. And we end up with a y of positive 1. So our ordered pair solution is 2, 1. Application. A florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? Let X be the number of regular bouquets, and Y is going to be the number of mini bouquets. So one of our equations is going to represent our roses. Our other equation is going to represent our peonies. Okay, so X is the number of regular bouquets. Y is the number of mini bouquets. We have 5 roses in the regular bouquets, and X represent the regular bouquets, so 5X is going to represent that amount. And then our minis, we have 3 roses, and the minis are represented by Y. So 5X plus 3Y is going to equal the total amount of roses, which is 118. Now for our peonies, we have 11 peonies in our regular bouquets, and X represents our regular. So 11X represents that amount, plus 5Y to represent the minis is going to equal the total of 226. In order for us to figure out how many of each type of bouquet can the florist make, we would need to solve the system. All right, so our system right now, I am going to need room. So our system right now is 5X plus 3Y is going to equal 118. Second equation, 11X plus 5Y is going to equal 226. So you choose where you want to focus. I am going to focus in front of Y. All right, so I have 3 and 5, which has a least common multiple of 15. 5, 10, 15, and with 3 is 6, 9, 12, 15. So the smallest one they have in common is 15. And remember, we want one negative, one positive. So my first equation, I'm going to multiply it by negative 5 so that I get that negative as my coefficient in front of Y. In the second equation, I am going to multiply by 3. Then I'm going to rewrite the system. So distribute, make sure you multiply by all 3. We are going to end up with a new system of negative 25X minus 15Y is going to equal negative 590, and 33X plus 15Y equal to 678. We're then going to add our system. Of course, our Y's cancel. We end up with 8X is equal to 88. And when we divide 8 on both sides, we get our X of 11. Now that we know X is 11, we can go ahead and substitute into one of the original equations. I am going to use the equation 5X plus 3Y equal to 118. Substituting X with 11, we have 5 times 11 plus 3Y is going to equal 118. We then have 55 plus 3Y is going to equal 118. Subtract 55 on both sides. 3Y is going to equal 63. And when we divide by 3, we end up with a Y of 21. Now, we can find our solution, but it's even better if we know what our solution represents. So remember, X represents the number of regular bouquets. So if X is 11, we have 11 regular bouquets and 21 minis that we can make. What is the solution to the system of equations? So because of how these equations are set up, for these type of examples, you have to figure out what method you're going to use. You have graphing, substitution, and elimination. Our first equation, we have y by itself equal to x plus 13. So our x and our y is not aligned. So what I would use is I would use substitution, which was learned in section 4.2 to solve that system. Second problem is set up like the problems that we've been working on in this section. So I would definitely use elimination to solve. So to use substitution, if y is equal to x plus 13, you should be able to completely replace y with that expression and rewrite the equation as 2x plus 7 parentheses x plus 13 close parentheses is equal to 10. We're then going to distribute. We end up with a 7x plus 91 here. You're going to bring down your 2x, your equal sign, and 10. 2x and 7x is 9x. Bring your 91 to the other side of the equation so that it cancels. And 9x is going to equal 81. And when we divide by 9, we end up with an x of 9. And I need to fix something. 10 minus 91 is negative 81. And negative 81 divided by 9 is negative 9, which is very important because it can throw your y completely off. All right, now that we know that x is negative 9, we can find y using our first equation, which is y equal to x plus 13. So if x is negative 9 plus 13 is y. So y is going to equal 4. So our ordered pair solution is negative 9, 4. Part B, we're going to use elimination. Looking at our coefficients on y, I have a negative 2 and a negative 4y. If I multiply this first equation by negative 2, it's going to give me a positive 4y, which will cancel with that negative 4y. So my new system, I'm going to distribute this negative 2, is negative 16x plus 4y is equal to 16. Second equation, we didn't do anything with it, so we just bring it down. We add our system. Our y's cancel. We end up with negative 11x is going to equal 33. We then divide negative 11, and we end up with an x of negative 3. Knowing x is negative 3, take one of your original equations. I'll take the second. And completely substitute x with what you found it to be, which was negative 3. Five times negative 3 is negative 15. We're then going to add 15 to the other side of the equation. And I'm running out of space here. So we end up with negative 4y is going to equal 32, for which we'll need to divide negative 4, and y ends up being negative 8. So our ordered pair solution is negative 3, negative 8. Go ahead and pause the video, complete to try it on your own, and then unpause to check your solution. So they want to know, what is the solution of each system of equations? Explain your choice of solution method. So because everything is aligned, your x's are aligned with each other, and so are your y's, I would use elimination. So with elimination, I am going to focus on my coefficients on y. I already have one negative and one positive. If I multiply my second equation by 6, it's going to give me that negative 12y, which is going to cancel with that positive 12y. So to rewrite the system, 6x plus 12y is going to equal negative 6. 18x minus 12y is going to equal negative 162. We're going to add. Our y's cancel. We have 24x equal to negative 168. We divide 24. And x is going to equal negative 7. Knowing x is negative 7, I'm going to take my second equation, substitute x with negative 7. We get negative 21, for which we have to add to the other side of the equation to that negative 27. Negative 2y is going to equal negative 6. And then when we divide negative 2, y equals 3. So negative 7, 3 is our final solution. And there's your concept summary.